Welcome to our first day of statistics. So we're going to look at classification and representation of data. We're going to start with the classification part. So there are two types of data, two main types. We're looking at quantitative and qualitative data. Quantitative data is data that is numeric. Qualitative is a description. So anything involving numbers is quantitative, while if we're looking at and counting the number of red cars, blue cars, yellow cars, and purple cars, now we're talking about a quality of that data, and that's what we're keeping track. So color of cars or color of hair, anything that is a description of something is considered qualitative. A lot of what we deal with in statistics is quantitative, though, and there's two main types of quantitative data. There's discrete and there is continuous. Discrete means countable. That's an important word for us. Anything that's countable, anything that has exact values is discrete in nature. Continuous is measurable. Continuous data is a measurable quantity. So an example of discrete data would be the number of shoes you have in your closet, or the number of students in a class, or the number of hot dogs you can eat, the number of whole hot dogs. Continuous would be the weight of the hot dogs that you can eat, or the height of a person, or the weight of a person, something like that, something that's measurable. Now, this is not to say that discrete data cannot have fractions, but only if it's a countable number of fractions. So maybe how many half hot dogs can I eat? I can eat 1/2, a whole, 1.5, 2. Only those exact values is what I'm counting. I'm not measuring the total. Now, when we talk about data, we talk about an entire population. If this circle represents the entire population, that's difficult to collect data on. The entire population would take way too long to make an effective study. So what we usually do is we take a sample from within that. So a sample is a subgroup of the entire population. And when we do this, what we're looking at is usually taking a random sample. That's how we collect our data. And what a random sample is going to have is everyone or everything has the same chance of being selected. And it also, if it's a good random sample, will closely mirror or do a good job of representing the population that it's a sample of. So if we're talking about the population by gender, our sample should have roughly the same proportion or the same percentage of males and females. If we're talking about race, our sample should have roughly the same percentages of each race as our population. And populations don't always have to mean everybody in the world. Our population could be all of the students at our school, or our population could be all of the people that live in Arizona, or it could be everybody in the United States. There's a lot of different populations that we can define. But what we do with this, what we do with these random samples, is we organize data. And you might be saying, wait a minute, you misspelled organize. Well, ladies and gentlemen, this is an IB course. We're going to do a lot of spelling the IB way, the European way. So we organize our data, and a lot of times that's in tables. And then we visualize data. And this is with graphs or charts. So here we go. Let's get into the meat of this. Let's do some data analysis. We're going to start with bar graphs. So we have cars that pass the house in 1 minute intervals for 30 minutes. the results were 23 cars the first time, 22 cars the second time, 22 cars the third time, so on and so on. Display this data in a frequency table, then draw a bar chart for this data. So what we're going to do is we're going to count the data that would go in each group. So easiest way to do that, since this data is not in order, we're going to create tally marks. So we go through and we count up how many 20s there are, how many 21s. Each one of these marks is a count, a tally for the things in that group. And then we count the number of tallies. And that is what we call the frequency. It's the number of times each of those shows up. In our bar graph, notice the horizontal scale, 20, 21, 22, 23. We're going to center a bar above each one of these. And with a bar graph, these are countable measures. These are discrete. Our bars are not going to touch each other. So the first bar above the 20 is going to go up to 2 because there are 2 things there. The second bar above the 21 goes up to 5 because there are 5 things, and then 7. And pause the video right now and try to complete this graph on your paper. Hopefully your bar graph looks like this. We have a bar above each one of these numbers, and the bars do not touch each other because this is discrete. Another way that oftentimes this is done is you'll do the tick marks on the x-axis right at the number, and the bar will be centered on that tick mark, but again, not touching. When you make a graph, make sure that you label the x-axis, make sure you label the y-axis here, and your scale should be consistent and evenly spaced in both directions. Okay, so here we go. We have a big list of data. We have the ages of 200 members in a tennis club. Is age data continuous or discrete? That's an important question when we're looking at data. The age here is continuous, technically speaking, because these groups, these classes that we're going to organize our data in, we're going to organize them in groups from 20 to 25, 25 to 30, but not including 30. Another way to give this interval right here would be like that. Closed interval at 20, open interval at 25. So that's another way to give it. But notice the bar stops right before it hits 25. That class stops there. It would be way too many bars if we did one for 20, one for 21, one for 22, 23, all the way up to 69. So we organize it into groups. Usually, when you are creating one of these, generally it's a good idea to stay between 5 and 7 classes, 5 to 7 groups. This is a little bit more than I would probably do, but it's going to give us a good idea of what's going on. So we're going to go through and count how many things go in each group. And since this data is in order, that makes our lives so much easier. There's our frequency. And we're going to use this to create a histogram and a frequency polygon. To do this, we need 2 things. We're going to need the classes here, the frequency, but to make this frequency polygon thing, we're going to need one more piece of data. And that piece of data that we need is the midpoint or class mark. The way we're getting that is we're taking the 20 and the 25 and adding them together and dividing by 2. We're taking the beginning of each class and finding the average of them, the mean. So here we go. We're going to make a histogram. We'll draw this by hand. So 20, 25, and evenly spacing these, 30, 35, 40, 45, 50, 55, 60, And this is the age, and then this would be the frequency. And of course your penmanship would be better than mine. And so how high do we have to go? We have to get all the way up to 42 for this count right here. I'm going to go by 5s. And again, evenly spacing this. And now we can draw our bars. From 20 to 25, we're going to go up to 4. So this bar would be roughly that big. 25 to 30 goes up to 12, so a little bit higher than the 10. And because this is continuous data, because this is a histogram, these bars are going to touch each other. So notice the finished product here. Notice I did flatten out my x-axis. I did a real job of drawing a slanted line there. It's important that when you do this, you are fairly accurate with your scale and the straightness of the line segments that you're drawing. But here's our finished histogram, bars touching, and the width of each bar corresponds to the width of each class up here. So now we need our frequency polygon. And the frequency polygon, what's going to happen is it's basically a connected dot plot. And what we're going to do is we're going to be plotting ordered pairs essentially here. So the x-coordinate will be 22.5. Above that, we're going to go to a height of 4. The next x value on the x-axis is going to be 27.5. We're going to go up to 12. And this looks like this picture. Notice that above the x-axis, there's the 22.5, there's the 27.5, and I'm up at 12, at 4, and notice I'm connecting all of these points. So all of these points are coming right from my table, and I just connect the dots. Those are all the values that are in that frequency column. The x value down here, and I would usually label my x-axis with the class marks, but that's where they're coming from. Okay, next example, last example, here we go. Here are the exam scores for a group of 24 students. The maximum possible mark was 90. Construct a frequency distribution with mark intervals 0 to 9, 10 to 19, and so on, and find the cumulative frequencies for each mark interval. So, I would like you to pause the video and fill in what these mark intervals are, the 0 to 9, so on and so on. So hopefully you have those marks, those classes in there. And the midpoints, or which those are usually called the marks, take a second, pause the video, and find your class marks. The midpoints. Now, why didn't I do 0 and 10? Well, what you have to look at is this data. This data is not continuous. This is discrete. This is the score on each exam. We're not counting decimals. You can have 0, 1, 2, 3, 4, 5, 6, 7, all the way up to 90. So when we find these midpoints, we're going to do 0 plus 9 divided by 2. And now that we have the mark in the midpoint, I want you to count the frequency. So pause the video and fill in that column. You should have those frequencies. And from that, from our marks and our cumulative our frequencies, we should be able to make our histogram. So pause the video. Let's go ahead and label our x and y axes and get these bars drawn in. So we should have something that looks like this. Now notice where each bar starts. This bar starts at -0.5 and goes to 9.5. It's going 0.5 smaller and 0.5 bigger than these endpoints because it is discrete data. So this first class on our graph is going from 0.5 to 9.5. It's still a histogram, but it's discrete, and it's grouped discrete data, and that's the delineation between when we use this histogram and when we use the bar graph. So what's the deal with this cumulative frequency thing? Well, what it does is it counts the number of things that are less than or equal to that group. So there is one item that is less than or equal to 9. But there are 3 items that are this group or smaller, because there was one already and we added 2 more on. How many things are less than or equal to this one? Well, there's going to be 5, ladies and gentlemen. And then 8, and then 13. And when we're all done, at the very bottom, we should have the total number of things in our group, because there are 24 items that are this group or smaller. Our cumulative frequency polygon, which is what we're going to draw now, or ogive, it's called, would look like so. This one, notice we start at 0 with a cumulative frequency of 0, and then 9 has a cumulative frequency of 1. 19 has a cumulative frequency of 2. We're using the upper limits of each one of these. We can think of these classes as being less than 9, less than 19, and so on down here. That's what these dots are representing. They're at 9, 19, 29, 39, 49, 59, 69, 79, 89. These ogives, these cumulative frequency polygons, should always increase. They will never, ever go down. And the last thing we'll talk about today is something called skewness. If we have a diagram of our data that looks like this, this is not skewed. It's roughly symmetric. It's normal. If I had a bar graph that looked like this, this would be skewed left. It looks like it has a tail extending out to the left. If I drew a curve over it, it is not symmetric. There's all this extra stuff on the left. Take a moment and sketch what you think a skewed right graph would look like. And there's a lot of different ways to draw this, but when it's all said and done, there needs to be a tight bunching on the left with a long tail extending to the right, something like that. So there's our visual and table representations of data, and from here, it's time to practice.